Welcome to this physics lesson on relative motion in non-inertial reference frames. Let's look at the following problem. An elevator car whose floor-to-ceiling distance is equal to 2.7 meters starts ascending with constant acceleration 1.2 meters per second squared. 2 seconds after the start, a bolt begins falling from the ceiling of the car. We need to find A. the bolt's free fall time, and B. the displacement and the distance covered by the bolt during the free fall in the reference frame fixed to the elevator shaft. Let's visualize this problem. We have an elevator with a floor-to-ceiling distance of 2.7 meters. The elevator is accelerating upward at 1.2 meters per second squared. Initially, both the bolt and the elevator start from rest. At t equals 0, the elevator begins accelerating upward. After 2 seconds, when the elevator has already gained some velocity, the bolt begins falling from the ceiling. Now, let's solve part A, the bolt's free fall time. First, we need to understand that we're dealing with two reference frames, one fixed to the elevator shaft, the inertial frame, and another fixed to the elevator, the non-inertial frame. In the elevator's reference frame, the bolt experiences an effective acceleration that's the sum of gravitational acceleration g and the elevator's acceleration a. So, the effective acceleration is 9.8 plus 1.2, which equals 11.0 meters per second squared. Using the kinematic equation for displacement, S equals 1/2 g effective times t squared, where S is 2.7 meters, we can solve for the time t. For part B, we need to find the displacement and distance covered by the bolt during free fall in the elevator frame. In the elevator's reference frame, the bolt simply falls from the ceiling to the floor. So the displacement is 2.7 meters downward, which is the height of the elevator. Since the bolt falls in a straight line, the distance covered is also 2.7 meters. Let's also analyze the bolt's motion in the reference frame fixed to the elevator shaft, which would be interesting to compare, even though the problem doesn't ask for it. In the shaft frame, both the elevator and the bolt are moving. The elevator starts from rest and accelerates upward. When the bolt is released after 2 seconds, it has the same upward velocity as the elevator, which would be 1.2 meters per second squared times 2 seconds, which equals 2.4 meters per second. Once released, the bolt continues with this initial upward velocity, but now it also experiences gravitational acceleration downward. This results in a parabolic motion, where the bolt initially continues moving upward, reaches a maximum height, and then falls back down. Let's summarize our findings. For part A, the bolt's free fall time in the elevator frame is approximately 0.7 seconds. For part B, both the displacement and distance covered by the bolt during free fall in the elevator frame are 2.7 meters. The key insight in this problem is understanding that in the non-inertial elevator frame, there's an effective acceleration that combines gravity and the elevator's acceleration, making objects fall faster than they would on stationary ground. Thank you for watching this physics lesson on relative motion in non-inertial reference frames.